Okay, now, what do we have here? We have a data set that we first of all want to explore. It is a data set that explores women wages of the 1988 National Longitudinal Survey. This is a data set that is available in the Stata library. The advantage is we can all access it directly. It's kind of built in to Stata. Everything that I need to do, first off, is to wipe my memory. That's the first command that I'm executing. You have now two options. You can highlight these lines of codes that you want to run and then click on this run button up here. What I'm going to do is I'm hitting the Control D command on my keyboard, and that will automatically execute those highlighted lines or rows in my script. The set more off command keeps data running when we have a very long code. It doesn't stop. Otherwise, you would have to click to continue the computation. It's a standard setting that I always put on. Now, this data set is a data set that contains information on wages, and you see a few variables here. Let's take a quick look. So we have IDs for the individuals in the data set. We have their age. We have race, we have whether they're married or not. Then we have whether they have been married before. We have the grade, the number of years in school. We have geographic information, the industry they work in, whether they're in a union. We have the wage, the hours worked, the experience they have with tenure, and so on. So it's a typical survey data set that contains individual level information on people that have worked, and in this case, in 1988. The first thing that I'm doing is I'm preparing a few variables that I will need. The first one is the log of wages. Typically, wages tend to be skewed. We have a few people that earn very little, and then we have a few that earn a lot, such as now the boss and the team. And that skewness will also lead to a situation where we have some outliers. And the log kind of takes care of that distribution. As a result, the interpretation of my coefficients related to wage will also be related to a percentage change, which is a common convention in wage research. That's a little bit of background. Now, what I want to do is I want to create a variable that is binary if the job that this person takes is a blue collar or a white collar job. Blue collar would be something like agriculture, manufacturing, so labor intensive work. And then blue collar work would be more cognitive related works, you know, something like a lawyer, a service person. Those jobs would be white collar. That is what I'm doing here. I'm first creating this binary variable based on the occupation that is present in the data set. If we recall, now there was an occupation variable here, which has operatives, craftsmen, sales, other professional, technical, different professions that we see here. And this binary variable then captures whether this occupation falls within the blue color or the white color category. I use that specifically to later have a binary outcome variable for my logistic regression. That's just a preemption. Let's create this, and then we can also look at those variables on the left. We see that we have a few descriptive statistics. First of all, how the variable race is distributed. It's a categorical variable with three expressions, white, black, and other. And then for blue color workers versus white color workers, I see also the distribution. 69% of the occupations in the data set are white collar jobs, and then around 30% are blue collar jobs. That's all that I need for now. That's just the two variables that I will work with in my regressions. Everything else is already in my data set. I can work with that directly. Part 0. We go to descriptive statistics. The very first thing that I tend to do when I work with data is to look at descriptive statistics. Nothing fancy, just the raw data illustrated. And that helps me to understand the distribution of the variables and their variance. When we look into regressions later, what we are looking for is variables that have a lot of variance. If they don't have a lot of variance, then typically things become very difficult to predict because regressions work with variance. First thing, therefore, is to look at what is the distribution like, what is the variance like. Let's take a look at this first plot. It is a k-density function, which is similar to a histogram really, but smoothened out. It shows me how the values of, in this case, the log of wages is distributed. If I look more closely at the code, I see that we have two groups here. We have union is equal to 0, which means that in this case, the person is not part of a union. And then we have the wages of those who are part of a union. That's why this is set to 1. Remember, union is one of the variables in our data set, and it has two expressions, whether you are in a union or whether you're not in a union. And this allows me now to see whether the distribution of wages for union workers is different from non-union workers. All right, let's take a look at this code. The two-way command creates that plot, and the k-density is the function that I'm using for this plot. What I see now are two nice lines. The blue one is the wages for union members, and the gray dashed line is for non-union members. And what we already see here is that the wages for the union members tend to be slightly higher than for the non-union members. That's a first descriptive result. In terms of the code, what we see at the bottom here is mainly options. For example, how I want the legend to be displayed, which font size, for example, that's the font size, which position on the clock, where that would be positioned. Now it's positioned at 11 o'clock, so that's upper left corner. I also specified the background color to white and the plot region to white. Then I added labels such as for my X title. Now that's the label for my X axis and the Y axis. And I also provided a title for the graph. All of this is optional. You don't have to do it. Stata has a standard form. If you don't specify any of this, then it will work with the default. But those options are typically a nice way to improve the visualization of this graph. And this logic of having a standard command like two-way and then the type of plot you want to use, followed by the option, that's the format we will use for all the figures in our later regressions as well. Same logic always. You have your standard visualization command, then you have a comma, and after the comma, you have all the options for improving and adjusting your visualization. The final thing is I want to export this. You have different ways to export this figure. You can export it as a JPEG, as a TIFF. That's what I chose here. You can use a vector graphic, which can be easily scaled. That's all up to you. The width and height is the size of the image. If you want to have a high resolution image, you just add more pixels to the width and the height, and then you're done. The other thing that I specified here is the directory for saving my graph. If I run this command, then I actually can go to my webinar folder, and now I can open this image, and there we go. I have it ready to export. You can see here there's a slight mishap. So the figure here looks, so the box for the legend is actually now too small. An easy fix for this internal error of Stata, so to say, is to simply add a few empty spaces after a union member, for example. Now, I just wanted to highlight this because that happens quite frequently, these little things. So if you just add a few spaces here, for example, after union member, then it should look fine. Another plot that I want to share is the graph bar. That's another figure that we can use to show a bar chart. In this case, I want to plot again ln wage. If I just use the first part of the code, graph bar ln wage, then that would already result in a figure that is okay. Now it looks not too terrible, but of course that is just with the inbuilt Stata default setting in terms of the colors, in terms of the labels. If I want to beautify this a little bit, I can again add my options. Now the type of labels I want to use, the type of colors I want to use. So let's run this as well. And you see now it looks a lot smoother in terms of the colors. We see again the mean log of hourly wage on the y-axis, and then we split this up by white collar workers and blue collar workers to see if their means in salary is different. And we already see, okay, there seems to be a slight difference in those average wages. That gives us a first indication, maybe that's something we can explore later in our regressions. Again, I'm going to save this to my document folder, and then I can draw on it again. So here, that's my final figure, and that's what I can then also use as an output for my paper, for example.